All right, here is the video for notes 8-2, confidence intervals for proportions. So the confidence interval for a population proportion, P, is P hat plus or minus Z star times the square root of P hat times 1 minus P hat over N. So let's just break down what each thing represents. So P hat represents your estimate, which is your sample proportion. Z star represents your critical value, and that relies on whatever level of confidence you're using. And then this whole part is the standard deviation of your sampling distribution. And just so we know, this whole second part after the plus minus, so the critical value times the standard deviation of your sampling distribution is your margin of error. So when calculating a confidence interval, we basically take the margin of error and subtract it from your sample proportion to get your lower bound, and we add it to your sample proportion to get your upper bound. Just like in the previous unit, we do have conditions for estimating P that must be checked before doing any calculation. So what's nice about these conditions is they should feel very familiar because they're essentially identical to the previous unit. So the independent condition is that big N is greater than or equal to 10N, so your population is bigger than 10 times the size of your sample. Your normal condition, the only difference from the previous unit is instead of using P, we're using P hat, because remember, we're estimating P in this particular unit. So N times P hat is greater than or equal to 10, and N times 1 minus P hat is greater than or equal to 10. Then we would say our population or our sample is approximately normally distributed. And then lastly, the random condition is the same. It's usually stated somewhere in the problem. So we must always check conditions before performing any type of calculations. So one thing I do want to go over is where those Z star values are coming from. Remember, Z star is basically based off of whatever confidence level you're looking for. So here's an example of how the T star values or the Z star values found. So find the critical values for a 90% confidence interval. So what we're trying to do is we're trying to find a 90% confidence interval, which means we're looking for this part of our distribution. Well, to figure out what our critical values are, so where we're going to cut off our distribution, we're going to take our confidence level, 90%, subtract it from 1, or 100%, which would leave 10%, and then we're going to divide that by 2 to figure out how much goes in each tail. So remember that these three numbers here, the 5, 90, and 5 should add up to 100%. What we're trying to figure out is where is this cutoff point to separate the middle 90% with the rest of the distribution. So what we need to do is we're going to basically use a z-table backwards to find the z-score associated with the lower tail area. So we're just going to figure out what is this z-star value. So to do that, we're going to look up 0.05 in our z-score table. So here's our z-score table. We're using it backwards since we have a proportion. So we're looking for 0.05. which the closest thing to 0.05 is somewhere going to be between these two values. And the z for that is going to be negative 1.6, and it's kind of in between this, so I'm going to say negative 1.645. So going back here, we know that it's going to be negative 1.645 would be the lower bound, and then that means the upper bound would be positive 1.645. So the z-star value for a 90% confidence level is going to be plus or minus 1.645. So let's look at another example here, 80% confidence interval. So to sketch what that looks like, we're looking for the middle 80%. Well, if 80% is in the middle, that means we have 10% to give here and 10% to give here. So to figure out what z-star value we're going to use, we need to figure out what is this cutoff point. That's going to give me my negative z-star value. So I'm going to look for the closest thing to 0.10 on my z-score chart. All right, so here's my z-score chart. We're going to find the closest thing to 0.10, which looks to be 0.1003, and the z for that is going to be negative 1.28. So that's going to be negative 1.28, which means this one is going to be positive 1.28. So the z-star value for 80% confidence is going to be plus or minus 1.28. So you aren't going to need to know how to do that by hand. However, it's always a good idea to know where these numbers are coming from. You can find the critical values for z-stars on table D, which is your t-table, which we're going to learn how to use later in this unit. It's on the back of our z-score table that I gave you, and if you look at the bottom row, so it has our z-star values. These are z-star values for some common confidence level. So for instance, a 95% confidence interval, we would use 1.96, would be plus or minus 1.96. 90%, which we found in that example, is 1.645. All right, so now let's actually look at a confidence interval for proportions example. So in this example, it says the New York Times and CBS News conducted a nationwide poll of 1,048 randomly selected 13 to 17-year-olds. It says we can consider the sample to be an SRS. Okay, and then it says of these 1,048 teenagers, 692 had a television in their room. It says construct and interpret a 98% confidence interval for the proportion of all people in this age group who had a TV in their room at the time of the poll. So starting with step one, we're going to identify our symbol. So the three symbols that we're going to identify for proportions is N, P hat, and then we're going to figure out what z-star value we're using. Okay, so N is our sample size, and we know that that's 1,048. P hat is the proportion of teenagers who had a TV in their room from our sample. So for that, we're going to use these two numbers, 692 over 1048, which is going to give you approximately 0.66. You can just round to two numbers if you'd like, since it's a proportion or percentage. And then the z-star value is going to be based off of the confidence level. So we're looking at the z-star value for 98%. So looking back at your where the z-star values are listed, the z-star value that we're going to use is 2.326. All right, in step two, we're going to define our parameter. So essentially what we're saying is, what are we estimating? What population proportion are we estimating? So that's usually given to us in the last sentence. So it says, we're calculating a confidence interval for the proportion of all people in this age group who had a TV in their room at the time of the poll. So I'm going to define P as the true proportion of teens aged 13 to 17 who had a TV in their room at the time of the poll. So in this step, we're just defining what the parameter in words. I just realized I was on the wrong slide, so this is actually step two. Define parameter. All right, so now we have step three. We're going to check our conditions. So our three conditions are the independent condition. So big N, we need to figure out what is big N. Well, we know our sample is 1,048 teenagers, which means that big N is going to be all teenagers aged 13 to 17 years old, is greater than or equal to 10 times our sample. So 1048. Make sure you're using our actual sample size, not the number of teens who had a television in the room. We want the whole entire sample. So that's what? 10,480. That's definitely reasonable to assume that there's more than 10,480 teenagers. The normal condition, we're going to do N times P, so 1048 times 0.66. That has to be greater than or equal to 10. So when we put that in our calculator, 1048 times 0.66, well, that should be this many, because that's the proportion of teenagers who had a television in their room. It's going to be off a little bit due to rounding, so we get 691.68, but we can see when we round, that's the 692. That's greater than or equal to 10, so that's good. And then we do N times 1 minus P hat. And when we put that in our calculator, that represents the number of teens who did not have a TV in their room. That is equal to approximately 356.32. That's greater than or equal to 10, so that's good. So that means that our distribution is approximately normal. And lastly, for the random condition, it does state SRS. So SRS is stated. All right, step 4, we're going to do our calculations. So remember our calculations for a confidence interval, looking at our notes, it's going to be p hat plus or minus our margin of error, which is z star times p hat 1 minus p hat over n. So p hat is our estimate, is our sample proportion. That's 0.66 plus or minus z star, which was 2.326, times the standard deviation. So when we put that in our calculator, we get 0.66. So I like to put our margin of error. So I put this entire thing in my calculator to get my margin of error. And if you put it in correctly, you should get 0.0340. So that's your margin of error. Which means that's going to give you your lower bound if you subtract it. So 0.66 minus 0.340 gives you a lower bound of 0.626. And it's going to give you an upper bound of 0.694. So your confidence interval is 0.626, comma, 0.694. So you should list your lower bound and then your upper bound. So lastly, interpret in confidence or in context. So to interpret in context, we're going to start with we are 98% confident that, and then we're going to look at step 2 where we defined the parameter, the true proportion of teens. So I'm just going to skip the 13 to the 17 part. Who had a TV in the room? Is between 0.626 and 0.694.